All right, yesterday we were looking at what's called compositions of functions, where basically, if you have a composition of functions, you take the output of one function and you turn that into the input of another function. So, a very quick illustration here. If I asked you, we'll go to something even simpler. If I asked you in question 3 what f of g of 1 is, so this is a, and I've just rewritten it with that function notation that we learned yesterday. You need to know that that means you're going to find g of 1, and whatever you get for g of 1, you're going to put in for x in f to find f of g of 1. So what we said was a good kind of visual template to look at is what a is saying is you're going to take 1 and feed it through the function g to get some output of g, which becomes the input of f, and that leads you to your answer. So in this particular case, in question 3, you would have to put 1 into this function and figure out that 3 times 1 minus 2 is 1. Yes? And that means you're getting 1 out of g. So that can be thought of, I suppose, as a y coordinate on g. But what it becomes is the x coordinate on f. So when I put that 1 in for x and f, I'm going to have 2 times 1 plus 8. And, you know, doing this all in your head is not always the best idea on an exam. It might be better to write it down so you can see the numbers, but I believe I'm getting 10 here. You know, on the other hand, if you take a look at something like this, it doesn't matter which one. Let's do A again. F of g of negative 4 means you're going to take negative 4 and feed it through g to get some intermediate result, which you're going to feed through f to get an answer. The only difference here is you're not putting negative 4 in for x in an equation, you're putting it in a graph. So negative 4 is an input. There's negative 4. I want to look at the output on g. Well, the output on g is 0 for a y coordinate. When x is negative 4, the y coordinate on g, the output on g is 0. So that means this intermediate piece is 0. That's going to now go in for f. So now I reset all of this and I look at an x coordinate of 0 and the y coordinate, well, I can't really draw an arrow there pointing to the y-axis because it's on the y-axis. The y coordinate is 2, which means the answer here is 2. And that leads us finally back to question 1, where maybe you don't have a graph and you don't have an equation, but you're just told that, for example, something like g of 2 is equal to 5. You need to know what that means is this. There's lots of ways to write that. We could write what that means is this. We could write what that means is this is a point on the graph. You can interpret it in a lot of ways. But you might have to use that additional information in the questions in order to determine inputs or outputs. Does anybody have any questions at all from anything that was assigned as practice yesterday? Go ahead, Farhan. Did you say 9? Okay. So we have j of x equals x squared, k of x equals x cubed. Does k of j of x equal j of k of x for all values of x? You know, if we're going to say that those two things are equal to each other, for all values of x, that means we can't start putting in numbers and deciding if some numbers work and others don't. What you need to do is use almost the same kind of approach that we did with proofs. Let's write k of j of x as a left side statement and j of k of x as a right side statement, and we're going to work on each of those separately. And if we end up with the same result, since we didn't use numbers, we used algebra, then that means the two results will always be the same regardless of the numbers used. And I want to add one little exception here, which doesn't really apply in this question. As long as we get the same thing on both sides, then they're always true for all allowable values of x. If there were non-permissible values of x, we don't include them in our analysis. There won't be because x squared and x cubed are polynomials. So what does this mean? I'm going to write this out. K of x is equal to x cubed. J of x is equal to x squared. Did I get that right? Yes. So what does k of j of x mean? It means we're going to take j of x, which is this, and put it in here for x. Whereas, on the other hand, what does j of k of x mean? It means we are going to take x cubed, that didn't work. It means we are going to take k of x, which is x cubed, and feed it into j of x. Over here we were taking j of x and feeding it into k of x. So this x cubed is going to go in for x. Just in for the x, not in for the x squared. So what we're going to get on the left-hand side will be, well, k is the input cubed, and the input is j, which is x squared, so we get x squared cubed. On the other hand, j, I'm looking at the function j, is a quantity squared, and the input, or the quantity we're squaring, is x cubed. And you can see right away that you're going to get x raised to the 6 regardless. So what this is saying is, in this particular case, if you square something and then cube it, and you decide to go back in time and go, I'm going to cube it first and then square it, it's not going to matter. But be very careful. We're not saying f of g of x is always g of f of x. It's not. Does that make sense, Brian? Okay. Other questions? All right, so the problems we're going to be working on today, this is on page 20 of your unit handout. These problems are going to be more complicated. So the difference is a matter of complexity today. So we are going to be analyzing composite functions and function operations that involve more than two functions. And notice this second bullet is combining compositions with operations. Remember, operations of functions are when you add functions together or subtract them or multiply them or divide them. Whereas compositions are where you take one function and feed it into the second function, or possibly the third. So things are going to get a little more complicated. To begin with here, this is a little bit of a brain teaser, but I've seen something similar on a diploma exam. If h of x is f of g of x, and h of x happens to be x plus 2 squared plus x plus 2 plus 3, then what are two possible values, or not values, what are two possible functions for f of x? In other words, I want you to come up with a function for f of x, which means it's going to have x's in it. And then I want you to come up with a function for g of x, where if you put g of x every place there's an x in f of x, you would get that function. And this one is not that difficult because you can see there's an x plus 2 that's being squared. You can see there's an x plus 2 that's not being squared, and there's a 3. So really, that function, that composite function, is some input squared plus some input plus 3. And if we make that input x plus 2, then we can write those two functions. I don't believe there's an algebraic solution to this problem. I don't believe you can just set out doing algebra and get the answers. You have to be able to see it visually. So just to rewrite this, f of x, I don't like those brackets. I just did that for explanatory purposes. X squared plus x plus 3 is f of x. And I hope you see that if you were to put this in for x, you would get the function given. Make sense? I had a student say this to me one time a few years ago. If this were a written response, could I write the following? And the student wasn't trying to be cheeky. She was being serious. And just think about that. She was saying, well, why don't I just call f of x the function I'm trying to get, and g of x is going to be x, which means f of g of x is going to be found by replacing every x in f of x with whatever g of x is. And she said, well, I'm just going to choose g of x equals x. And she's right. That would be correct. It would, right? But I'm not sure you would want to roll the dice on a diploma exam and try to be clever about it. I think there's a different intention there. Okay. Let's try one more. I think this second one is actually, well, I don't know. I think it's a little bit easier. When you start thinking about what a function is an operation that occurs on something. Well, there's an operation that's occurring here on x. It's being tripled and then adding 1 to it. But there's another layer of the operation, which is that you're square rooting the result. So if you say that g of x is 3x plus 1, the outer operation can just be the square root of that. We're looking at finding something that we can substitute in for a square root to get the square root of 3x plus 1. So that thing would be 3x plus 1. And again, these are weird questions. This first example is weird. Because like I said, it's kind of a visual thing. It's like you either see it or you don't. And it's not an algebraic approach. But I feel as though I would not be doing justice to the course if I didn't show you this in case you see it on an exam. Does anybody have any questions with A or B? All right. So the next question is an application of operations of functions and composites of functions. And it gets a little more difficult here because we're not just dealing with x and y. We're actually dealing with a number of different variables. So when you take a look at your first equation here, you're told that when you drop a rock in the water, you create a circular ripple, and those ripples move outwards. Okay? And as a result of them moving outwards, you're told that the radius of the circular ripple can always be found by taking 0.25 times the time in seconds. You might notice that when I went from here to here, I dropped the function notation because, quite frankly, r of t is confusing. All r of t means is the radius depends on the time, and the radius is found by inputting a time. I want you to appreciate what this formula is used for is to take a time and feed it through this formula and get a radius. By the way, for you sciencey, physicsy people, the reason that works is the ripple is spreading outwards at 0.25 meters per second. That's the speed of the ripple. So if you multiply speed by time, you get distance. On the other hand, you're told that the area of the circular ripple, this should be no big surprise, is pi r squared, right? I mean, that's the area of a circle. And again, I've changed something just ever so slightly when I went from the formula given in the question for area to what I've written here. I dropped the pretense of the function notation. It's A of r equals pi r squared. All that means is the area is a function of r, and r is the input to produce the area, just like f of x has an input of x. And I want you to make an observation here that what this is used for is to take r and calculate an area. So if you were asked for a composite function, a of r of t, what you were asked for is something, I need to rewrite this, I don't have a lot of room. If you were asked for this, what you were asked for is to find some function which would allow you to take t to get an r, and then take that r to get an a. So the inner variable is time, the outer variable is a. That's the goal. How can we calculate a directly from the time? And that's why these two green little diagrams underneath the two formulas are important. If I were to take, it's not going to be perfect, but if I were to take this and put it over top of this, you can see what happens here. This is what we're asked for. This is the function highlighted in blue. This is the function highlighted in green. What you were asked for is this entire function. This is a of r of t. And once you understand that, it's not difficult. All we have to do is take 0.25t and put it over here for r. We're not dealing with a specific number, we're dealing with an entire expression. You probably could have been given this question before this unit, and if I just said find an equation for a that depends on t, you would do an algebraic substitution. But that's all composite functions are algebraic substitutions of one function into another. So anyway, we end up with a equals pi times r squared, but r is 1/4 t. I'm just putting that 0.25 as a quarter because I don't want to deal with squaring 0.25. I mean, I think when you square 0.25, you get 0.0625. I don't know. But I know when you square a quarter, you get 1/16. It's easier for me. So I need to square the quarter, I need to square the t, and we end up with area equals 1/4 squared, which is 1/16 times pi times the t squared. Any questions with example 2? All right. We've got a lot of examples today. It's going to be like rapid fire with a lot of these. You're given in question 3 functions, and look what you're asked to find. You're asked to find a new function k of x, which is, and this is how I would pronounce it, which is f plus g times h of x. All that means is this new function. This has nothing to do with compositions. It will be f of x plus g of x multiplied by h of x. It's multiple operations on multiple functions. Well, f of x is 3x minus 2 plus g of x is x squared minus 4 multiplied by h of x, which is x over x minus 2. I didn't put it up here. I suppose we could add this, but it's kind of unsaid. Clearly, x would never be allowed to be 2 in that function. And since x is not allowed to be 2 in that function, and that function forms part of k of x is never allowed to have an input of 2. That domain follows the whole process along. What do we get? We get k of x equals 3x minus 2. And then when you multiply, you can multiply across the top. So we get x squared minus 4 times x over x minus 2. I didn't multiply the x squared minus 4 by the x and write x cubed minus 4x because we have to simplify this. This needs to be simplified, and it's a rational expression. And to simplify a rational expression, you don't multiply stuff out, you factor stuff. So that x squared minus 4 is a difference of squares. I can factor the numerator, well, part of the numerator as x plus 2, x minus 2. And then I still have that other factor of x, and this is over x minus 2. So what happens is the x minus 2's cancel. You've been exposed to enough of these illustrations before that I hope you understand, even though we canceled the x minus 2, x is still not allowed to be 2. Right? That non-permissible value is there till the end of time in this function. But what I'm left with is k of x equals 3x minus 2 plus x plus 2 times x. And I see no reason why we wouldn't multiply that out now to get a nice quadratic function. So k of x is 3x minus 2 plus x squared plus 2x. Just rearranging the order of those terms. We can write k of x, this function we're after, is x squared plus 5x minus 2. How's my algebra this morning? Does that look okay? Good. And again, you know, if you really want to wow a diploma exam marker for a written response, you would say, well, yeah, but x is not allowed to be 2. All right, next one. What is h over f times g? Well, that means h of x over the product of f of x and g of x. And you don't need to put a multiplication sign between f and g. So let's just load the functions in. And again, we're going to be dealing here with a rational expression of some kind. H of x is x over x minus 2 over, when you have multiple, it's not multiple fractions, when you have a complex fraction, like you have a fraction over something else, make sure you really understand that that long line I've drawn is the big fraction. It's what separates the numerator and denominator of the big fraction. And then I have to multiply these two, which is 3x minus 2 by x squared minus 4. This is a rational expression. You never multiply stuff out in a rational expression before you try to simplify it. You always factor things. Now, there's two things that need to be done. One of them is factoring, which I'm going to do first, and then I'll tell you about the other one. I get k of x equals, in the numerator I have x over x minus 2, and then in the denominator I have 3x minus 2 times x plus 2 times x minus 2. So that's the first thing that really ought to be done, is factor everything. Then you want to eliminate the complexity of this fraction. In other words, it's a complex fraction because in this case, in the numerator there's a mini denominator. That mini denominator I will just highlight for you so you know what I'm talking about. I don't mean mini like it's tiny. I just mean I call it a mini denominator. We've got to get rid of that. We don't want fractions within fractions. So I'm going to multiply the top of the entire fraction and the bottom of the entire fraction by x minus 2 to cancel that x minus 2 and get k of x equals x in the numerator over, I'm going to have a 3x minus 2. I'm going to have an x plus 2. And sadly, or maybe happily, I don't care what your outlook is here, nothing cancels, right? We don't get a chance to cancel those x minus 2's or anything. We end up with x minus 2 quantity squared on the bottom. And that's the answer. I suppose you could say, looking at the original functions, we used all three of these, so x cannot equal to 2 because of h of x. As well, x cannot equal to negative 2 because we were dividing by x squared minus 4. Yeah.
What happened to the x?
Did I lose an x somewhere along the way?
Yeah.
Oh, look at that. Oh, wait, no, just a second here. So are you talking about this x, Grant?
No, I'm talking about in the actual equation there's an x.
This? that's not, I mean, I'm going to sound like an idiot here. That's not an x. Of course that's an x. We can see it's an x. But that is not the variable x being multiplied by anything. What that is saying x is the input of this function. It's, you know, if I want to, do you understand that this x I'm pointing to is this x? Okay, so it's just, it's a product of, not product, bad word. It's a result of the function notation. It's not an actual variable that's being multiplied by anything. Does that make sense, Grant? Okay. All right, let's take a look at the third one. What? H of g of f of x. What does that mean? It means that f of x is going to go through g of x, and the result is going to go through h of x, and this will be our answer. But this is not going to be a number, right? We're not feeding a number in for x. We're feeding the whole function. So what's going to happen, and I don't know if you want to write this or just look up here, but f of x, this whole thing, needs to go here just for the x in g. And whatever that whole thing is, that's going to go every place there's an x in h. Remember, we go from the inside out. So f of x is going into g, and then the result is going into h. So if we put 3x minus 2 through g, what are we going to get? We're going to get 3x minus 2 squared minus 4 coming out of g. And this is a question you could have been given yesterday. And I suppose right now you could simplify this. Why don't we do that? You don't have to simplify this now. You could put this thing in for x here and here and then simplify it. But I would prefer to simplify it at stages. I'm going to get 9x squared minus, I better not do that. Don't forget 3x minus 2 quantity squared is that. Okay, so I will write what I just erased, but you need to know how to get that. You need to FOIL that out and get 9x squared. We're going to have minus 12x because my outer will be minus 6x and my inner will also be a negative 6x. And I'm going to have plus 4. Oh, that works out pretty good, doesn't it? Because then I have the minus 4, so at least my result, which is g of f of x, is just 9x squared minus 12x. So 9x squared minus 12x, you don't need to write this in here. I'm just going to, drive the point home that that's the result of the first layer of what's going on here. That is going to go in for x in h. So the answer is going to be k of x will be that thing, which is the input in h, 9x squared minus 12x, over the input minus 2, which is 9x squared minus 12x minus 2. Complicated. It's not hard complicated. It's complicated to think about and to organize the thought in your head as to what it is you have to do. The math itself is pretty basic. Questions with C? All right, one last one. H of g of x, which means g of x goes through g. So this that you're getting out here, this is g of x, and then that's going to go through h, and whatever you get for an answer will be h of g of x. So g of x is going to eat itself. We're going to take g of x, which is x squared minus 4. We're going to put it in for x and get x squared minus 4 squared minus 4. make sure I'm looking at the right function, h of g of x. G of x goes into g of x, so x squared minus 4 goes in for x in x squared minus 4. I don't want to simplify this because that's not the point of this lesson. I don't want to FOIL out a quadratic and get a degree 4 polynomial. That's unimportant. That now is going to go through h, so our answer is going to be, well, h has an input of x on the top. Our input is x squared minus 4 quantity squared minus 4 over the input minus 2, which is x squared minus 4 quantity squared minus 4 minus 2. I'm not going to waste the time to write minus 6. You can change that minus 4 minus 2 to minus 6. And again, I'm not too concerned about multiplying this out because then we're going to have to reteach polynomials all of a sudden at this point to find non-permissible values, and it's going to get a little ugly. Okay. All right, number 4. Oh, back to numbers. That's good. We're given 3 different functions here, and you're asked for f plus g plus h of negative 2. You should understand that that means f of negative 2 plus g of negative 2 plus h of negative 2. This is not a difficult question. There's just a lot of moving parts to it. You need to put negative 2 in for x in each of these functions and get 3 different y coordinates, which you then have to add. We're in learning mode right now. If this were a written response, you wouldn't just do what I'm about to do, which is to write negative 2 here. I'm putting negative 2 in for x in f of x. So on an exam, I would write 3 times negative 2 plus 4, which equals to negative 2. Please check my arithmetic this morning. When I put negative 2 in, and that's plus, when I put negative 2 in for x in g, I get negative 5. And again, if it were an exam, you would show your substitution. Negative 2 squared, quantity squared gives you 4. 4 minus 9 is negative 5. When I put negative 2 in for x in h, I might be inclined to just do this on paper anyway to make sure because it's a little more complicated, but I believe you get negative 2. You'll get negative 2 over 1, which is negative 2. So this is negative 9. Yeah, neat little numerical response question. F plus g plus h of negative 2 equals negative a. What's the value of a? 9. Oh. G of h over f plus g of 2. Well, this means g of h of 2, and I want to pause for a second here. I hope everybody understands, is bilingual enough to understand what I just wrote. I could have written this way. And in fact, I'm kind of flipping back and forth between the method that I use. They mean the same thing, all right? So that's what the numerator of this new function or this problem is. The denominator is f of 2 plus g of 2. So to find the numerator, you're going to feed 2 through h, then take the result and feed it through g. To find the denominator, you're going to feed 2 through f and feed 2 through g and add those numbers together. Again, if it's a written response, you're going to have to explain this in some way. I'm just going to put for the numerator that we're taking 2 and feeding it through h. We're taking the result and feeding it through g to get the numerator. N for numerator. I put 2 in there, I get, oh man, you get 2/5. Okay. And then I put it through g. I have to square 2/5 and subtract 9. You know, nobody cares on an exam how you're going to get that. Figure it out. Negative 221 over 225. Sorry? Over 125. Good? Thank you, Sienna. Over, well, what's f of 2? We put 2 in for x in f and get 10. We put 2 in for g and get negative 5. I believe we have 10 plus negative 5. I just want to make sure. It is negative 221 over 125? Oh, that's the total thing. Okay, that's the total thing. It is, the numerator is negative, you were one step ahead of me, I should have checked. The numerator is negative 221 over 225. Better check. So what I'm doing here is I'm taking the 2/5 and I'm putting it in for x. So I'm taking 2/5 squared minus 9. 2/5 is 0.4 squared minus 9. Oh, it's over 25. I wasn't even close. It's over 25. So negative 221 over 25. And the bottom of this is 5. When you multiply the top and the bottom by 25, what you're going to end up with is the 25's canceling and getting what Sienna told us the correct answer is, which is negative 221 over 125. Any questions with that one? Okay, I'll give you a second to do this one. G of f of h of 3, that means you're going to put 3 through h, take the result, put it through f, take the result, put it through g. Does anybody have an answer? I could be wrong. I skipped a couple steps, which I probably shouldn't do. But when I put 3 in for h, I get a half. 3 divided by 3 plus 3 is 3 over 6, which is a half. So 0.5 is what's coming out of h. I need to put that into f. So times 3 plus 4. I get 5.5. I was wrong. I was thinking you were getting 4.5, so this is not correct. I get 5.5. And then I have to square that. And you know, at some point, there's nothing wrong with using your calculator. Minus 9. 85 quarters. Good. Again, just in case you're unsure, or maybe somebody's watching the video later, what's happening is we're putting 3 through h. We're taking that answer, feeding it through f. We're taking that answer, feeding it through g, and getting the answer to the question, which is 85 quarters. This gets tedious after a while. What this is saying is f of g of negative 1 over h of negative 1 times g of negative 1. So I'll give you a minute to calculate h of negative 1 times g of negative 1 to write a number in the denominator, and also to calculate f of g of negative 1. This, of course, is negative 1 being fed through g, being fed through f. H of negative 1 and g of negative 1 are just found by putting those numbers in. Evan, can you tell me what you got for the numerator? In other words, what is f of g of negative 1? I got negative 20 as well. And then h of negative 1 is, correct me if I'm wrong, h of negative 1 is negative 1/2. G of negative 1 is negative 8. Oh, this worked out really good because negative times negative is positive. 8 times 1/2 is 4. We have negative 20 over 4, which by my ciphering gives me negative 5. Okay, so now we're going to be dealing with a graph. We have some functions here that are given graphically. What is f minus g of negative 5? Well, that means f of negative 5 minus g of negative 5. How do we find f of negative 5? We go over here to negative 5, and we look at the y coordinate on f. F of negative 5 is 4. How is it we determine, I'll just use a different color here, g of negative 5? Well, we go over to an input of negative 5 and we look at the y coordinate on g, which is 6. So we have 4 minus 6, which is negative 2. What's going to happen in B? Farhad? Right, I'm just subtracting them in the opposite order. And this was actually a question you or somebody else had asked the other day when we were talking about differences of functions. Though they will be opposite because you're subtracting in the opposite order. I mean, I suppose I could write g of negative 5 minus f of negative 5, and then I could write 6 minus 4, but you're going to get the opposite because you're subtracting the 2 points in opposite orders. What is f times g of 3? Well, what's f of 3? F of 3 is found by looking over here at 3 and looking at the y coordinate, which is 2, on f. Coincidentally enough, that's also the y coordinate at 2 for x on g. So f times g of 3 is going to be 2 times 2, which gives us 4. Any questions with A, B, or C? What is g of f of 3? So I want to see if you can get this on your own. I'm not doing this to try to trick you or anything. I want to see how many of you can get this on your own. And I would warn you that if you're not thoughtful, even though you might understand what you need to do, it's easy to make a mistake. Okay. It's 1, right? When I feed 3 through f, I get 2. And we just did this one. When I look at x equals 3, and I'm looking at the function f, the y coordinate is 2. So 2 comes out of f. Now I need to put 2 into this function. And this is the point we're talking about, which has an output of 1, so the answer is 1. All right. Figure out for me, please, what f of g of 3 is. So this other one was g of f of 3. Now I want you to see if you can figure out what f of g of 3 is. And I think, unless I'm mistaken, you're going to have to do some estimating here. Yeah? It's not going to end up on the crosshairs of a particular readable point. I would say 2.3 or 2.4. Can you live with that? So what's happening is, again, I don't want to assume everybody knows exactly what's going on. 3 has to go as an input to G to get an output. That output has to go as an input in F to get the final output, which is the answer. So on G, which is here, I'm going in with an x of 3. What comes out is a y of 2. Now I need to, on here, go in with an input of 2, and the output is, as I said, I'm going to go with 2.3, but we don't have to quibble over it. If you said 2.4, that would be fine. So the answer is 2.3. All right, have at her. F of g of f of 3. $2.7. Three goes through F. That result goes through G. That result goes through F again to get our answer. So I'm just doing this in case some of you are confused by this. I hope nobody is, but 3 is going in, and we are looking at an output on F, which is 2. 2 now goes in, and we're going to be looking at an output on G, which is 1. 1 now goes in, but we're looking back on F. One goes back in, but we're looking at now an output on F again, which gives me, I'm just saying 2.7. I think you can live with 2.7 is our answer. I think you get the point, but let's just try one more. G of f of 4. How many of you have it just within a few seconds? Is it 1? I think it's 1. So 4 goes into F. What's going to come out is 1. 1 goes into G. What comes out is 0. 0 goes into G. What comes out is 1. So hopefully you're becoming masters at this. Determine the domain of each function. So what is the domain of f of x over g of x? I'm asking you. Can somebody tell me what the domain of f of x over g of x is? Evan?
Well, x has to be less than or equal to 4 and can't equal 1.
Good. So we're going to start with x has to be less than or equal to 4. And I like the way you said that. You said, well, x has to be less than or equal to 4. That's kind of the starting point. I like the tone of that. And it has to be less than or equal to 4 because if it's greater than 4, f of x doesn't exist. So you can't talk about dividing functions when one of them doesn't exist. But then you also said and or but x cannot equal to, x is not allowed to be 1? Okay. And why is that, Evan? Right. And remember, we're dividing by g of x. So where is g of x 0? Don't forget, when I say g of x, I mean the y coordinate on g of x. G of x is 0 right here. A function equaling 0 is an x-intercept of the function. And since we're dividing by g of x, you would be dividing by 0 at that x value of 1. So we have to include that. What's the domain of g over f? Ryan, you want to give it a shot?
It's similar that x has to be less than or equal to 4, but x cannot be 3?
No. X has to be less than or equal to 4. And we're just going to end it there. Now, you said 3. You wanted to have a non-permissible value because we're dividing. But this point right here where you said x is 3, that's allowed. Those y coordinates are both defined. Since we're dividing by f of x, we would have to exclude any points where this function, where that function has a value of 0, and that function is never 0. In other words, when we said x can't be equal to 1 here, it was because there was an x-intercept at 1 for the function we were dividing by. If we're dividing by a function that has no x-intercepts, then it will never be 0, so we don't have to include it. Does that make sense? Good. If f of x ended up doing this, then it would obviously be less than or equal to 5, right? But it would actually be, if that's what it looked like, the domain would be x is less than 5, because it can't be equal to 5. So every case could be a little bit different. Subtracting functions, just the common domain. We don't need to worry about restrictions. So the domain here would be x is less than or equal to 4. Still good? Okay. This is different now. This is the one question that I started off the lesson by saying at the end there's going to be something that is different. And this is the one that students have the most difficulty with. This says g of f of a equals 98 and asks you to find a. This is not telling you what number goes in to start this process. It's telling you what comes out in the end. So what this is saying is there's some number that we want to find. This is our goal. That is going to go through f, and f of x, which it's going through first, is 2x plus 4. Whatever we get there goes through g of x, which is x squared minus 2. And what comes out is 98. That's what comes out. And we're asked to work backwards and figure out what had to go in to begin with to produce that 98. Well, when you look at the 98 coming out of g of x equals x squared minus 2, what this is telling us is 98 equals x squared minus 2. It's what comes out. And we can figure out from that what must have gone in. And if you solve that little equation, you can add 2 to both sides, and you'll have 100 equals x squared, which means there are 2 possible numbers that could have gone in for x, positive 10 or negative 10. Either of these numbers going in for x and g of x will give you 98. And this is math 30. We can't just say, oh, well, let's just use 10. The square root of 100 when we solve an equation is plus or minus root 100. It's plus or minus 10. So now the top part of this is saying, and I want to be careful here. I hope you understand I am not saying 2x plus 4 plus 10. 10 is what's coming out of 2x plus 4. So one of the solutions to this can be found by taking the output of f of x and working backwards to find the input. And the other solution would be found by taking the other output that could have come out of f and setting it equal to 2x plus 4 and getting the solution. Yes, Naya?
Can't you also just make a composite function and then just do it all in one shot?
You could. I would, and I would be fine with you doing that, and I would be fine with a few other people doing that. Your question is a good one. Yes, it will work, but I wouldn't teach it that way because I think it would confuse too many people. What Naya's saying is she could figure out what g of f of x is, simplify that, and set it equal to 98 and do that. If I solve, I'm not going to spend time solving this. I better get it right. That being said, I subtract 4 from both sides and get 6 equals 2a. So x here is equal to 3. Am I right? Okay. The other equation, the other possibility is I subtract 4 from both sides and get negative 14 divided by 2 is negative 7. So there are two possible values of a. Am I right there? Negative 7? Okay. So a legitimate Math 30 question. I give you the context here. G of f of a equals 98. I give you the functions. And I say the two possible values of a are blank and blank. I don't like that as a multiple choice question, everybody, and I think you should know why. Because if I give you the answers, you can feed them in and see if you get 98. So I would rather redesign this as a numerical response question where maybe the two answers are both positive, and I ask you to enter the two answers as A and B, or whatever letters you want. J of h of a is 0, which is h of x or y equals sine of x. Then it goes through j, which is y equals log base 3 of x, and we get nothing. We get 0. That's what's coming up. So what I need to do here is solve this equation, 0 equals log base 3 of x, and you get 1. Because if we convert log base 3 of x equals 0 to exponential, we'll write 3 to the 0 equals x. 3 to the 0 is 1. So we now know that 1 came out of h of x, and that means 1 equals sine of x, and it's a basic trigonometric equation to solve. On the unit circle, sine of a rotation angle is 1 at the top. At pi over 2 radians or 90 degrees is a location. So this is the rotation angle. X, which is pi over 2, plus multiples of 2 pi, where n is an element of the integer number set. We've done this before, but it was a while ago, and trig is trig, right? It's tricky. That x, when I say x equals pi over 2, that's not the x coordinate on the unit circle. That's the rotation angle. Any questions with that one? Things are starting to come together here. We're starting to, because now we have all of the operations on functions, compositions of functions, transformations of functions. Any function you learn about is fair game in this course. I don't believe, does yours say F? Do you have this question? Okay, it doesn't matter what it's. Let's figure out this one. Finally, we put A through J first, which is log base 3 of x equals y. We take that output and we feed it through K, which is y equals 2 to the x, and we get 8. I'm just curious if how many of you see what the answer is almost immediately. Like you've sorted it out already. This last part means that 8 is equal to 2 to the x. So what goes in for x to get 2 to the x equals 8? Well, that's a basic exponential. That's not even an equation. That's a fact. 2 cubed is 8. So x is 3. Now we have to say what goes in for x in this function to get 3 coming out. Well, 3 equals log base 3 of x means 3 raised to the 3 is x, so 27 is what you said in your head. So the answer is 27. And that's it for today. That's it for the unit. I do have a review handout I will give you that has a variety of different practice problems because some of you like to get started a little early. Your exam is Wednesday of next week, so we are officially reviewing Monday and Tuesday. There's a whole boatload of problems that you can use to practice here. Any questions with that final set of problems where you're working backwards? All right, so you got about 15 minutes here, and then we'll be done for the week. Well, done this class for the week. Get to work. I got to do something quickly at my computer, then I'll come around and check on you.